So we have finished chapter 2, lessons 1 and 2. But as I'm teaching, there are times that I realize that some of us are struggling with a particular concept, or maybe a couple of the lessons that we've done in those concepts. And I'm not the type of teacher that just wants to say, I'm going on no matter what. I need you to have a strong foundation of this information that we covered in order to be able to be successful this year and in junior high and high school. This is your base foundation of understanding fractions and decimals and how they're related. And we're expanding upon this lesson after lesson after lesson. So here's the important part, the most important part that I can tell you about these videos and extremely about this lesson. You have to follow along. You have to pay attention. This is all about you taking notes. This paper that I've given you, it's front and back, and I'm working every single one of these problems in this video with you before I give you your assignment. So please make sure you're taking your notes. Number one, your brain, I know, will be engaged if you're filling out your paperwork. Now that's on today's lesson, on the front and back of this paper, or in your book. Just simply do it, and your brain's going to be engaged, and you're going to be learning with me. I have a couple of you that you're letting the video play, you're watching everybody else, and when you see the answer written on the board, on these slides, you push pause, and then you fill out your book. And that's basically drawing. So like in my paintings in the back of my room, I can look at an image and I can duplicate something that I see. That's the way my art skills work. I can't just sit down and create my own image. My brain doesn't quite process that way. I'm a duplicator, and I enjoy duplicating, and that's fine. It would be okay if this was art. This is math, and this is math that you need to understand from now up through the next 4 years of math, and then probably as you go on, you'll have to understand it as well if you choose to continue on in those higher math classes. So please follow along, and please make sure you're doing it as we go along. You're going to be following along, your brain will be engaged, and you're going to create this muscle memory that as you work through it, you're going to get the information. Now, this is kind of compacted, isn't it? A front side and a back side. So I would suggest, especially those of you whose letters are about this big and you don't know how to write according to the size of the space that you're given, get some paper. The thing about my slideshows is when I do them, when I see my typing, I have a certain size that I want to make sure I stay at in a font so that when I project it, you'll be able to see it better. So I can adjust that by size, and therefore if my space isn't enough, I just add a space inside the picture image that I put on there. You can't do that on your paper. You can't magically expand your paper. So I have all sorts of paper over here, right? Please get it. Please staple it to your assignment. Therefore, you can show me your work. And then if we run out, which I don't think we will, I've got a whole bunch in a box underneath where my inboxes are. It should last us at least through Christmas break. And then if we run out, then I'm sure that your parents have bought you paper to use for this school year. So just that little extra effort to make sure you're staying precise, you're organized, you're nice and neat. That's going to be vital, especially when I give you very little itty bitty spaces to write in. Some of you, like my oldest son, you adapt your writing to fit into tiny spaces. My son can write to the size where I have to use a magnifying glass in order to see it. So we're going to start with going back to the idea of what we learned this first lesson. Fractions are decimals and decimals are fractions. And we're going to use this from this point all the way throughout the school year. Have to have this understanding and this base knowledge. So we're slowing down and we're doing this review. Now, I would strongly suggest that if you have not learned your decimal place values, and I am not trying to shame anyone by saying that, I know some adults, they don't know their decimal place values. I have a minor in mathematics, so decimal place values was never a difficult thing for me to talk about. Okay? But if you don't know those, this is the only time I'm going to show it while we're reviewing it. You might want to copy those down on your paper by hitting pause now on that space bar and writing those down so that you know that we have a decimal point followed by tenths, hundredths, thousandths. It's going to be important. We're even going to have one as I'm working some of these that go out to the 10 thousandths position, showing that those decimal place values will always go on and on and on. All right, so we're going to start out. Directions are always important, and I'm hoping that you're reading directions, because when I graded the assignment on lesson 2 or 2.1, some of you missed a lot of points just because you didn't follow directions. This one says to write a fraction or mixed number, which none of these are until I get order to 5 and 6, as its decimal form. Write a decimal as its fraction or mixed number. So those three is where I'm going to have to write them in as a fraction. In order to write a decimal into a fraction, I have to know what they say. There is a shortcut to it, which I'll explain as I'm going through. But if I can read this and I know what it says, that it says, I say the numbers, 48, and I say the place value that the last one's in, hundredths, then I know that's 48 hundredths. That allows me to just write it as a fraction, as 48 hundredths. Now the shortcut, if you really struggle remembering those place values, is this. I write my digits as my numerator, and then I count my decimal positions, 1, 2, and I put 2 zeros behind a 1. That will always work. That will give me my hundredths position. 100 has 2 zeros. So that will always work. But it'd be really better for you if you could just learn 2 decimal positions as my hundredth position. So then as I create my fraction, then I always have to reduce a fraction if I'm able to. Now, on some of these, I'm going to be doing multiple steps here because there are 2 ways that I can reduce. And some of you, you're going to go step by step by step. It was my freshman year that I was still reducing step by step by step until my algebra teacher said, no, you have to reduce by your greatest common factor. We're 6th graders, and I don't expect you to reduce by your greatest common factor, but there are some of you in this class, you automatically see the greatest common factor, and that's fine. So I'm going to work on both so you can see that you'll get to the same answer. So when I look at them, if I go step by step, then I reduce by 2's because I know they're both even. And so I know 2 will go into 48 and 2 will go into 100. And if I don't know that mentally what that looks like, then I type it into my handy-dandy calculator. Well, 2 will go into 48 24 times, and 2 will go into 150 times. And then I look at that ones column, right? 4 and 0, still both even. Have to reduce it again. If they're both even and I know that 2 will go into them, I reduce. And once again, reducing is dividing top and bottom by the same number. 2 goes into 24 12 times, and 2 goes into 25 or 50 25 times. Now my factors of 25 are 1, 5, and 25. There's only 3 of them. And none of those will go into 25 out of the 1, which wouldn't change anything. So what that tells me is 12 25ths is as low as I can go. The other way that I could do it, if I notice automatically what my greatest common factor is, it might pop into my head, and I'm sure there's a couple of you out here that it does. My greatest common factor is 4. Notice if I reduce by 2 and 2, that 2 times 2 does give me 4. That's one of the ways I can know what my greatest common factor is. But if I reduce by 4, dividing top and bottom by the same number, then I know that 48 divided by 4, well, if I type it in my handy-dandy calculator, is indeed 12. And there are 4 quarters and a dollar, so that's going to be 25. Notice what happens. If I reduce step by step, or if I reduce my greatest common factor, I end up with the same answer of 12 25ths. All right, so now we go to the second one. Once again, if I know how to say it correctly as a decimal, I can write it easier as a fraction. That is said 8 tenths because I say the numbers and what number they make up, which is just 8. And then I say the place value that it's in, which it's 1 place value, so it's tenths. And then I write it as 8 over 10. The shortcut for those of you struggling to remember your decimal place values is just put a 0 behind a 1 in my denominator for every decimal place value that's represented. I put my 1 and notice there's 1 decimal place value and 10 has 1 0. It is a shortcut, but I'd like you to start learning what your decimal place values are. Once again, even numbers, I'm going to reduce by 2, and 2 will go into 8 4 times, and 2 will go into 10 5 times, and that's as low as I can go, right? 5 is a prime number, and 4 therefore won't go into it, so I know 4/5 has to be my answer. Now I look at this one. So I'll mention the shortcut first. What it should look like I have a 4. That's the only number up there, so I know it's going to be my numerator. And then I'm going to start my denominator with a 1, and I have 1, 2, 3 decimal place values represented, so I put 3 zeros behind that 1. That makes 1,000, right? Well, let's look at what this number actually says. I say the number that's represented, which is just a 4, and how many decimal place values are there? 3, so I know I have my tenths, hundredths, thousands. So this is said 4 thousandths. So if I write it as a fraction, I put 4 over 1,000. Now I'm going to reduce. They're both even. Reducing, dividing numerator and denominator by the same number. Dividing by 2's, so I know 2 goes into 4 2 times, and 2 goes into 1,500 times, right? But that's still both even. So I'm going to reduce by 2 again. And 2 goes into 2 once, and 2 goes into 500 250 times. Now, some of you might have thought, I know 4 will go into both of those numbers. Some of you, like me, your mind automatically thinks to money. And you thought, well, that 4 quarters goes into $10 how many times? If I reduce by 4's, which is fine, dividing by my greatest common factor, 4 goes into 4 once, and 4 goes into 1,250 times. I end up with the exact same answer. So my final answer becomes 1 and 250ths. 1 250ths. There we go. Not an 8. All right, so then this one says to take my fraction. That's my first directions, right? So I have to remember my numerator is my dividend inside my division box. My denominator is my divisor on the outside of the box. I enunciate those words like that so that you know there's an inside number and an outside number. Some of you did this first lesson and you wrote them down, and then you thought, I can't divide a small number by a big number, even though I kept saying it on the video, and you erased them, and then you flipped them, and it was completely backwards. I have to put my first number, my top number, on the inside. Since we're making decimals, one of the key things to that is just adding a decimal as I'm writing it down. I know I'm going from fraction to decimal, so just go ahead and add it to the end of it. Once I have it set up with my denominator as my divisor on the outside, I have to raise my decimal straight up, right? Because I have a decimal divided by a whole number. Has to go straight up so I know it's going to be in the right position for my answer. And then I'm going to add a 0, and then I'm going to divide. And 8 goes into 50 6 times, because 6 times 8 is 48, with a remainder of 2. I had 2 or 3 of you that then you had 0.6 or 2 as your answer. Can never happen. If I'm doing decimals, I have to continue to divide until I don't have a remainder. If I get out 5, 6, 7 decimal positions, then you've done something wrong. And the first thing I would suggest is making sure that your top number is on the inside. Because there were a lot of you that you ended up with 6 or 7 decimal positions because you had flipped them. Top number has to be on the inside. Can never have a remainder with a decimal. So I have to add zeros and bring them down until I have a balanced remainder. So I have a 0 and I bring it down, and 8 goes into 20, well, 2 times, because 2 times 8 is 16. That gives me a remainder of 4. Add another 0, bring it down until I have a 0 balance. So I have 8 going into 40. That's going to give me my balanced remainder, right? So 8 goes into 45 times, and 5 times 8 is 40. There's my 0. I know I'm done. So I have the answer of 0.625, but that's known as, correctly, 625 thousandths. I say the digits and what number they make, 625, and then that last place value is how I say it or I name it, which would be thousandths. So 625 thousandths. Now, number 5, these type of questions that were mixed numbers. Mixed numbers, a whole number with a fraction. Some of you messed up because you just didn't put your whole number with it. Some of you added an extra step that once you found your decimal, you just added your whole number to it. And that's the way the book shows you, and that is completely fine with me. If that helps you remember it, by all means, please do. Personally, what I do, because I find it easier, is I see there's a whole number, I just put it on my answer line. That way I know I'm not going to forget it. Then all I'm focused in on is finding what my fraction is as a decimal. So once again, my top number, my numerator, has to become my dividend going on the inside I go ahead and add my decimal. And then I'm dividing by my denominator, so that's my divisor, excuse me. So my dividend is 3, can't do that division, so I add a 0. 20 does go into 31 times, and 1 times 20 is 20, so when I subtract, I get a remainder of 10. Have to add a 0 and bring it down. 20 goes into 100 how many times? Well, 20 goes into 100 5 times, because 5 times 20 is 100. I have a balanced remainder. There's a 0. So now I'm just going to take my 1500ths and I'm just going to slide it behind my whole number of 7. If you don't like just writing down your whole number in your answer line, that's fine. And some of you want to show adding of 7. And that's fine. More than one way to do a math problem, I'm good with it. Just make sure that you do have 7 and 1500ths as your answer, and not just the 1500ths. There's a big difference. I can show you that there's a big difference, but if you're just thinking about winning the lottery, if you won 7.15, 7 and 1500ths, $1 million, or they say, well, 7 doesn't matter. I'm going to give you 1500ths of $1 million. You're not going to be happy if you throw $7 million out the window and say, yeah, it's the same value. So that whole number is quite important to my overall answer. Going on. We had a number line. This is where on the assignment some of you missed 4 points automatically. The reason being, you didn't read directions. You looked at it, you thought you knew what it wanted. The directions say to write it as a decimal and a fraction or a mixed number. The mixed numbers are on the other end there. So as I do a number line, I have to figure out what my tick marks are equal to, what their value is. Sometimes they're worth 2, sometimes they're worth 5, sometimes they're worth a 0.5 like we've seen already. So if I look at this one is worth 0.5. So how many tick marks are from 0 to 0.5? Well, there's 1, 2, 3, 4, 5, right? So on this one, each of these are worth 1/10. So if I start counting them, I have 1/10, 2/10, 3/10, 4/10, 5/10 is the one that's given. 6/10, well, that's my A, isn't it? All right, so I can identify that A is the same as 6/10. I'm good to go. No, I'm not, am I? Have to do the fraction form also. So if I say this as 6/10, I write that as a fraction, 6/10. I put my 6 over 10, and anytime I write a fraction, what do? Hopefully you thought. I see if I can reduce. I can reduce because those are both even numbers, so 2 will go into both of them. Reducing, once again, and I say this because I had a couple people when working with me last week, and I said, well, we got to reduce our answers. What does reduce mean? I have to divide top and bottom number by the same number. 2 goes into both, so I divide top and bottom by 2. That is reducing. 2 goes into 6 3 times. 2 goes into 10 5 times. Those are both prime numbers, and the 3 will not go into the 5 evenly, so that's as low as I can go. So I know the decimal point of 6/10 is the same as or equal to 3/5. B was the very next one, right? So I had 6/10, so this has to be 7/10. So I'm going to identify the decimal point, but then I have to do the fraction. This is said 7/10, so I write it exactly like a fraction. Now when I do, then I notice 7 is one of my first 5 primes, right? 2, 3, 5, 7, 11. And 7 doesn't go into 10 evenly, so it can't be reduced. So it's just the answer of 7/10 and the decimal point of 7/10. C then takes me over and beyond the 1. So if each of these were 1/10, I just make sure that each of those tick marks are also a value of 1/10. So this would be 1, 2, 3, 4, 5. It does take me to 1 5/10. So the one right before it has to be the 1 4/10 or 1.4. So when I write that as my decimal, it's just the 1 4/10. Then I have to write it as a mixed number, right? Also include the fraction or mixed number answer. Now, this is one of those, once again, if you want to do it later on, that's fine. But what I do, since I say 1 and, I know I have a whole number followed by a fraction. That's what makes it a mixed number. So I just put my 1 on the line. I say 1 4/10, so my 1's going to go there. My and 4/10 is what I have to make a reduced fraction. 4/10 is written as 4 over 10. I reduce because they're both even, and 4 doesn't go into 10 evenly, so I'm only going to have to reduce it by 2. 2 goes into 4 2 times, and 2 goes into 10 5 times. So then I take that number and I put it up here. Some of you prefer to then show +1, and that's fine. You're still going to get the same answer. Either way works, as long as you remember to include it, because 1 2/5 is not the same as 1 or as 2/5. Excuse me. So make sure you have your mixed number answer. And then D was right on the other side of that 1 5/10, right? So I know it's 1 6/10. So I identify it as a decimal. I say that it's 1 6/10. So the 1 and tells me put my whole number of 1. Now I'm going to write my 6/10 exactly how I say it, 6 over 10, and I'm going to reduce. 2 goes into both of them. So 2 goes into 6 3 times, and 2 goes into 10 5 times. 3 and 5 are both in my first 5 primes, right? 2, 3, 5, 7, 11, 2, 3, and 5. They can't be reduced. 3 won't go into 5 evenly because it's a prime. So I just keep it with my 1. So 1 and 6/10 is the same as 1 and 3/5 when it comes to a mixed number. All right, so if you didn't get any of that, I was going too fast. Hopefully you're learning by now after this first month of school. You're just pausing it and writing it down at your own pace, and that's fine. I tried to make sure that I take 40 minutes or less to teach the lesson. I'm halfway through, and I'm at 20 minutes. So we're still on good tracking for you to be able to take your notes and then have time to do your homework. Now, here's the magic trick. Take your paper, flip it over. And then we can begin on Chapter 2, Lesson 2, where we're comparing. Comparing. So once again, on comparing. Now this just shows you fractions, which would be a little bit easier, but we're doing fractions and decimals. That's why we have to understand Lesson 1. I do not care if you can tell me that this is a greater than sign, which it is, and that this is a less than sign. What I care about is that you know that the arrow always points to the smallest number, and you can have it pointing to the correct answer every time. So this is the smallest number because that's the way it's pointing, and this is the smallest number because that's the way that arrow is pointing. When I get into the lesson then, I've got fractions and I have decimals. Oh, Mr. B, I really don't like fractions, or I really don't like decimals. Well, on this first set, I want to work it both ways so that you can see either way to work it. Now, if you like fractions, then work the fraction ones on your paper. If you prefer decimals, write the decimal ones on your paper. The next set, I'm only going to do decimals, and I'll explain why when we get to it. Okay? But if you really want a good foundation of both fractions and decimals, write them both down so that you know how they both work and interact. The only one I'm not going to do both ways is this first one. Hopefully, this should be really easy and quick. Why? Because when I compare fractions, I have to have a common denominator, which I have. So if I have a common denominator, then all I have to look at is my numerators. I have a 5 and a 7. If you're not sure which one is smaller, hold up your hands for 5, and then hold up your hands for 7. I have to take 2 hands to make 7, right? That has to be bigger. Smallest number. Arrow will always point to the smallest number. All right, so that one's quick and easy. Not so much on these other ones. All right, so common denominators. Now this I know confused a couple of you, and it's not meant to confuse you, but it is math that has to be done starting in our very next lesson, which I'll talk about here in just a second, but it's going to come from your In Success book. When I use my fractions, common denominators just means, notice I made this red, hopefully you can see it on the video so you know what I'm talking about. I'm just going to take this and I'm going to put it over there. Okay? So if I want to put it over there, then my math that I do is multiplying, and I multiply top and bottom by the same number. Whatever this number is, I'm going to multiply both top and bottom to rename my fraction. All right? So when I rename my fraction, then I take my 9 times my 5, which is going to give me 45, and my 7 times my 5, which gives me 35. Okay, so now I go to my second fraction. I'm making that one blue for you. So I have my 7/9. I'm going to multiply over here, opposite side, by 9 over 9. It does change my digits, but it doesn't change my value. So if I multiply those, I get 9 times 5 is 45, common denominator, so I know I'm good to go. 9 times 2 is 18. Now, let me explain this real quick about not changing the value. If we have a pizza that's cut into 5 equal pieces, and you get 2 out of those 5, but you're like, I want more than 2 slices. And Mom says, okay, let's cut our pizza up into 45 little pieces. Now that would take a lot of cutting, and your pieces would go from about this big of a triangle of pizza down to really small. But you'll understand what I'm saying. So we cut our pizza into 45 little pieces. She's like, all right, so now you get to have 18 pieces. If I go back to my original amount of pizza that I'm eating, I'm having the exact same amount of pizza, even though I have 18 slices. Because when I multiply 9 over 9, well, 9 over 9 is the same as 1, right? Because it's division. 9 divided by 9 is 1. This is called a form of 1. It allows me to change the digits in my fraction for my numerator and denominator, but it doesn't change the value. 18 out of 45 slices of pizza is the same amount of pizza as 2 out of 5 pieces. If you don't believe me, well, the next time Mom makes pizza, try cutting it into 2/5 and then cut it into 18 45ths and compare the amount. It's going to be the same amount. The point of this, when I get my common denominator, then I can look at my numerators and tell which one is smaller. And that's the whole point of understanding it. I know that 18 is smaller than 35, so my arrow is going to point to the left. Now, some of you are like, oh, fractions. I don't like fractions. Can I just do decimals? Absolutely. When I have a fraction, I know automatically that it's division. And my numerator always goes on the inside divided by followed by a decimal, and I'm going to divide it by my denominator. So I have my dividend, which is the 2, my divisor, which is the 5, and now I'm going to divide. Don't switch them up because the smaller number can be divided by the bigger number. Just put the decimal point, bring it up, and then add a 0. 5 goes into 20 4 times. That's an even balanced remainder, right? So I know I have a 0, so my answer is 4/10. I'm going to do the same thing with 7/9. This is for those of you that prefer decimals instead of fractions. My top number, my 7, followed by a decimal, divided by my denominator, which is now my divisor, which is 9. Bring up my decimal anytime, and then add a 0 and divide. 9 goes into 7 times, because 7 times 7 times 9 is 63, and I get a remainder of 7. It's the exact same answer, isn't it? Well, if you pick up your handy dandy calculator and you take 7, type it in first, divided by 9 equals, you're going to get 0.777777. I don't know how many it's going to give. It depends on the size of the screen of your calculator. And then it ends with an 8. This is what we introduced last week. It's called a repeating number. If it repeats itself over and over again, I just put that line over it because I know the 7s will go on forever and all eternity. So 0.7 repeating. 1 decimal space, 1 decimal space. When I compare decimals, I have to have the same number of decimal spaces. 4 is smaller than 7, and guess what? It's the exact same answer. The arrow is going to point to the left. All right, so now we have decimals. Well, let's see. Decimals. Let's go ahead and start with fractions. This is said 7/10, so I'm going to write it exactly as it said. 7/10. 7 goes over 10. And this one is said 43 hundredths, so I'm going to write it exactly as I say it as a fraction. 43 is going to go over 100. Now, we could multiply by opposite denominators. If I did that, I'm going to get a denominator of 1,000 and 1,000. Then I'm going to get 700 and I'm going to get 430. There's a shortcut though. Anytime I have groupings of 10 in my denominators, and that is a 10, 100, 1,000, a 10,000, 100,000, so on and so forth, a 1 followed by zeros, then all I have to do is figure out what I'm missing. Well, here's a 10 and here's a 100. This has 2 zeros. This has 1. I'm missing a 0. So I'm going to add a 0 there. But whatever I do to the bottom, I have to do to the top. So I'm going to put zeros at the end of both of them. It's a shortcut to find a common denominator. Only works if I have groups of 10. So once again, 10, 100, 1,000, 10,000, 100,000, whatever they are, in the denominator. So if I add my 0, then I see that in my numerators, let's see, so 43 is smaller, right? So my arrow is going to point to the right. Well, let's say, no, can I just stick with my decimals? Absolutely. When I look at my decimals, I notice I don't have the same number of decimal spaces. Here's what happens pretty quickly. People will look at them and say, I got to get my homework done as fast as possible so I don't have anything to take home, and 7 is smaller than 43. Well, logically speaking, if I speak to a 7-year-old compared to a 43-year-old, yeah, the 7-year-old's a lot younger, right? But that's on whole numbers, and that's the only time that works. These are decimals. It's not the same, because we just said that the 43 was smaller. Well, that's when I compare decimals. They have to have the same decimal point place value, which is what I said on the 0.4 and the 0.7, right? All right. So if this has 2 decimal positions, this one has to have 2 decimal positions, which means I have to add a 0. And that proves this answer is correct, because 43 hundredths is indeed smaller than 70 hundredths. The only difference is that's not a proper number, so if I was writing down that answer, I'd have to take that 0 off. But to show my work and to prove that 43 hundredths is smaller, having that 0 is just fine, because I proved that my original answer is indeed correct. All right, so now on 4. We've got a decimal and a fraction. We've messed them up, haven't we? So now I got to do it one way or the other. So let's start with our decimals. Going into fractions, I have my decimal of 78 hundredths. Going into a fraction, I say it the way it is, 78 over 100, and I write it out. 21 over 25. Let's see. So I need a denominator of what? I need a denominator of 100, right? So once again, I could multiply by 100 on the right and multiply by 25 on the left, and then I'm going to get 2,500 as a common denominator and have to do some bigger math. Yet, there's an easier way to do it. If I have 100 as my denominator on this one, and I'm remembering that quarters are easier to think about because that's a denominator of 25 and this is a denominator of 100, so a quarter goes into a dollar how many times? It's easier to think, well, if I multiply by 4, because 4 quarters makes a dollar, which is 100 pennies. If I multiply numerator and denominator by 4, it's easier math to do, because that does give me 100, which in the top then gives me 84. And if I don't know it's 84 in this brain, then I take my handy dandy calculator. 21 times 4 equals, and it is 84. Once I have those with my common denominators, then all I have to do is compare my numerators. And 78 is smaller than 84, so I know I'm going to point to the left. Well, let's say you want to stick with decimals. I'm fine with that. This is 78 hundredths, right? So that one's already a decimal. Well, if I divide my numerator by my denominator, I put my decimal point behind my 21, I add or bring up my decimal, and then I add a 0 and I start dividing. 25 goes into 210. Well, quarters and $2, that would be 8, right? Because 8 quarters makes $2. 2 times 25 is my $2, which is 200. Or you take your handy dandy calculator, 210 divided by 25 equals 8 and stuff. Get rid of the stuff. It's still going to have 8. Then I have a remainder of 10. Add a 0 and bring it down. 4 goes into 1, or 25 goes into 100 4 times. So it's 84 hundredths. So when I look at it, and I know that I have 84 hundredths as my decimal here and 78 hundredths there, my answer once again is correct from before. My arrow is going to point to my left. Now on these, this is where I really suggest you have some extra paper. Remember, it's over here. Okay? There's going to be a lot of work on these, and I'm telling you, if you try to come up with a common denominator, some of them are going to seem virtually impossible to do. So these are where, if you really despise decimals, your work becomes a lot harder. Dividing them and making decimals is really the easiest way on these type of problems. So that's what I'm going to do. I'm not going to do the fractions on there because it is a lot more work than just simply dividing and coming up with decimals. So we're going to start out. We're going to put each of them in our division boxes and work through them. So I'm going to take my 1 and I'm going to divide it by 8. Notice I made a bigger box here. So I have to bring up my decimal and I have to add a 0 and then I start dividing. 8 goes into 10 one time because 1 times 8 is 8 and I get a remainder of 2. Have to add a 0 and bring it down. 8 goes into 20 2 times because 2 times 8 is 16. Get a remainder of 4. Add another 0, bring it down. Now I'm in my thousands position, and 8 goes into 45 even times. That gives me my balanced remainder of 0, so I know that this one is equal to this first one, and I try to make sure that they're lined up so I know what they correspond to. 1/8 is the same as 125 thousandths. All right, so now, when I go to my next one, I'm going to separate this one out so I can see where it is. And I have my numerator divided by my denominator. So I have 3 point, I have to add that decimal and bring it up, right? And then I do a 0. All right, so this is where I said that decimal points can go out because we got to go out 4 on this one. 16 goes into 30 just one time because 1 times 16 is 16 with a remainder of 14. It's smaller than 16, so I know that I can't go in it anymore. So I add a 0 and I bring it down. And then I have 16 going to 140. Well, doing that in my head, not so easy, but with my handy dandy calculator, 140 divided by 16 I know is 8. And then I check what that is. 8 times 16 is 128. Remember, you're going to get a decimal, an 8-point stuff, and you get rid of that stuff, and you only keep the 8. So now that I have 128 and I subtract those, I know that I'm going to have 12. When I have 12, I have my 0, my next 0, and I bring it down. I keep going until I don't have a remainder because it's not going to be even yet because 16 goes into 120 only 7 times, and 7 times 16 is 112. Have to subtract again. All up until this point, we've only gone out 3 decimal positions, but decimal positions will go out forever and all eternity. So I have to keep going until I have a balanced remainder. Take 80 divided by 16 and what do you get? We got an even number, don't we? So I get to stop. So I have my balanced remainder of 0. So I know I have, and this is how we say this. I say the number that the digits make up. 1,875. Then I say the place value that the 5 is in. 10 thousandths. So this is 1,875 10 thousandths. First one we've had with 4 decimal positions. Then I'm left with the 5/4, which I'm going to drop down here. And I'm not going to divide that out all the way. Why is that? Because my numerator is larger than my denominator, isn't it? So I know when I start dividing, I have a 1 as a whole number. And if I have a 1 as a whole number, I know that has to be my largest answer because this is a decimal and this is a decimal. So I know that my 5/4 has to be my last answer. It has to be greatest. And we're going from least to greatest. Now I have to compare these. Well, when I compare them, I see that this one has 4 decimal spaces, so I have to have this one as 4 decimal spaces. So that one just requires adding a 0. Once I do that, then I'm comparing 1,250 to 1,875, and I know that 1,250 is smallest. So this one was the 1/8. It has to be my smallest value. This one was the 3/16. That has to be my middle value. The original forms have to be my answers, and they have to be in the correct order. This is worth 4 points. I see my work. Notice I didn't have to finish this out. I got to a 1 as a whole. I can show that that has to be my largest one, so I can stop there. But I showed work for 3 problems. 3 problems. So that's 1 point. And then each of these in their correct spot is worth a point. If I have them completely switched and 1/8 is over here and 5/4 is over here, I'm only going to get 2 points. Work and my middle answer. They have to be in the correct order in order to get all 4 points. All right, so going on. Well, these two are already decimals, so that one's going to make this a lot easier. I only have 1 I have to work out. I'm going to take my 7 divided by 9, and I'm going to add my decimal point and a 0, and 9 goes into 7 times. This one seems familiar, doesn't it? That's 63. A remainder of 7. Bring it, still 7, and I could go on and on and on, right? So this is my repeating number again of 0.7, repeating. Now I went out twice, and that's because when I look up here, this one goes out twice. So if this goes out 2 times and this goes out 2 times, that one also has to go out 2 times. So I'm going to add a 0. Then I can put them in order from least to greatest, and you know what happens? I notice they're already listed from least to greatest. So I have my 7/9 as my smallest number, because it's 77 hundredths, followed by my 78 hundredths as a decimal, followed by my 8/10, which has a value of 80 hundredths. So it is largest, but I write it as the 8/10. All right, so now let's see, least to greatest. Something should jump into my mind when I see number 7. Hopefully you see quickly that this is my smallest number because my whole number is smaller than the 2 4s. So I can automatically write that down as my smallest number, and then I only have work for 2 different ones. But they both have whole numbers of 4, right? So I'm going to put my 4 and I'm going to put my 4. Now I just have to solve for my fractions and figure out which one goes where. So I'm going to take my 2/5, dividing numerator by denominator, add my decimal, bring it up, and then put a 0 behind. And 5 goes into 20 4 times. And that gives me my balanced remainder, right? So now I did my 1/4. Now maybe you know that 1/4 is also called a quarter. And a quarter is worth 25 cents. And 25 cents looks like 0.25. But we're going to solve it mathematically. So I have 1 point. I raise up my decimal. I add a 0. 4 goes into 10 2 times. Because 2 times 4 is 50, or excuse me, is 8. And then I subtract, I have a 2. And then I want to add a 0 and bring it down. And 4 goes into 25 times. And then I have my 0.25. 2 decimal spaces. I need 2 decimal spaces in order to compare. So that I know that's 40. And therefore, this one is smaller than this one. So I know my 1/4 has to be 4 1/4. And then my 2/5 has to be my largest value. All right, so my final one. Here we go. We're almost done. You get to work on your homework in just a second. All right, so I only have one I really have to solve, right? Because the first 2 are already decimals. So I take my numerator, divided by my denominator, I have 8 inside my division box, followed by my decimal point. Raise up my decimal point. Add a 0. 25 goes into 80. How many times? 3/4 is 75 cents. So it goes in 3 times. 3 times 25 is 75. I subtract and get 5. Add a 0. Bring it down, which is 50. That's where my brain was thinking because I looked ahead and that's where I got my 50. 25 goes into 50 2 times because 2 times 25 is 50. Balanced remainder, 32 hundredths. So let's see what I have. I have 2 decimal spaces, 2 decimal spaces, and 1. So I add my 0. Then I can put them in order from least to greatest. So my 32 is smallest. My 32 went with my 8/25, so that has to be my first one. 50 is my middle value, so I have my 0.5 or my 5/10. 67 was the largest value, so I have my 67 hundredths. They're in the correct order and in the correct form. That is the end of our review. So you have the back side, or the second page. There's a front and back side, just like our practice. I'll be passing those out probably within the first 25 minutes of you working, so it should already be at your desk. Make sure you do all of them, because that is your assignment. You have the second page that I've assigned, both sides. You're going to do front and back, all of them. Remember what we talked about. Watch this video as many times as you need to. Watch it at home if you're really bored. I'm so entertaining to watch. Tomorrow, you need your In Success book, because lesson 2.2a is in that book. If you have any questions then, please come and ask.